Hi, Geometry. How's it going? It is week 7. It's the second assignment, and we are going to continue looking at some special right triangles. We've talked about some trig ratios, and those dealt with right triangles. Now we're going to look at some 30, 60, 90 special right triangles. And yes, when I say 30, 60, 90, I am referring to their degree measure. So, this is the theorem. If you remember last week, I think with 6.1, we covered 45, 45, 90. That was an isosceles right triangle. Now we're going to look at one. It's not isosceles, but it's still a right triangle. And we have some pretty darn cool ratios with the sides that are going on here. So, our theorem, 30, 60, 90 triangle theorem in a right triangle. Yes, we have our right angle right there. Where the ratio of the angles is 30, 60. Oh my gosh, what happened? Where the ratio of the angles is 30, 60, 90, the ratio of the side lengths is x times the square root of 3, I'm reading right here, and 2x, where 2x is the hypotenuse. So, if we're looking here, I've got, this is kind of like my base side, all right? So this is kind of like what we're going to be building off of, right? If you have this length of x, one of your legs, and specifically this length of x, it's the side that is always across from your 30-degree angle. So if you know the side that is across from your 30-degree angle, you can find all the other sides by, well, my hypotenuse would be 2 times the length of x, and the other leg of the right triangle would be x times the square root of 3, all right? And the square root of 3 is a constant, and it comes out of the Pythagorean theorem when we're doing this. It is a constant, and I'm going to say square root of 3 is roughly, where is it on my paper? 1.73205, okay? So it's a constant that you just multiply x by. Same as this, right? 2 is a constant that you would multiply x by. One thing I want you to know, because we're going to be kind of doing this in reference to our shortest side, because I think that's a good place to start. Again, if you can find out what this side is, then you can find the other two by just multiplying by 2 or the square root of 3. So one thing I want you to notice, that the smallest side is always opposite the smallest angle, all right? So our smallest side here would be x. Our smallest angle is 30. They're opposite of each other. Same way by saying that the largest side, and the largest side would be 2x, is always opposite your largest angle, which is 90, right? This was in like chapter 10. This was a long time ago, all right? So here is my first example. Oh, I didn't draw that picture, but let's draw that picture real quick. Not with highlighter. Hang on. Oh my goodness. Okay, so here's my example. I'm going to draw a 30, I'm going to sketch out a 30, 60, 90 right triangle. So here is my right angle. Let's say that this is 60 degrees and this is 30 degrees. That means that my shortest side has to be the side that is opposite of my 30-degree angle. So what if I said that the shortest side was a length of like 6 feet or something, right? Can you find all the other sides? So this side, the hypotenuse, and if we peek our heads up here, we said that if you have the shortest side as a length of x, the hypotenuse is just double that. It's 2 times x. So double the length of my shortest side, so double 6 is just 12 feet. My hypotenuse would be 12 feet. The other leg here, this leg right here, would be x times square root of 3. So in this case, if x is 6 feet, then we would have 6 times the square root of 3, right? So this is just 6 square root of 3. And I plugged that into my calculator, and I estimated 10.39 feet. All right, I like to round to 2 decimals. Might be a good rule of thumb. So if you're given a special right triangle, 60, 60, 90 triangle, and you're given one of the sides, you can automatically find the other ones. All right. So I've got some examples. Let's go over a couple here. They're all going to be, I'm saying find the length of all side lengths. All right, so this is my 30, 60, 90. The only one that's not labeled must be 30. Therefore, this 3.5 would have to be my shortest side since it is opposite of my smallest angle. So I know that, whoops, I know that my hypotenuse is double the length of my shortest side, so it's 2 times 3.5 centimeters, which would give me 7 centimeters, all right? And the other leg would be 3.5 times the square root of 3, and then I evaluated that in my calculator, and I got 6.06 centimeters. So you're probably going to want a calculator today, just to let you know. Okay? So, again, just ratios that are going in here. Okay. I've got 10 centimeters. Let's take a look here. The only the only angle that's not labeled is my 60-degree angle, so I'm going to put that in here. Here's the difference, though, is that I am given the length of my hypotenuse. I'm given the length of my longest side. So I think the easiest way would be to find the length of my shortest side. Again, I know that the longest side, 10, is equal to double the length of my short side. So if I wanted to solve for x, if I wanted to solve for my short side, I would just divide by 2, right? Just cut it in half. So I would get that the shortest side here would be 10 over 2, would be 5 centimeters. Okay, and then just to find the other leg here, well, I know if I have my shortest side of 5 centimeters, I just have to multiply the other side by, multiply my 5 centimeters by the square root of 3, so this other side would have to be 5 times square root of 3, and then I evaluated that in my calculator, 8.66. All right, not too bad, not too bad. Let's do another one. I have my special right triangle. We're going to say that that guy is 30 degrees, and now we can see some information. Here, I'm giving the side that is opposite of the 60-degree angle. Again, when we're looking at this, we had x, what was the other one? 2x, and there was x square root 3, right? So if this is the side that corresponds with x square root 3, and this is our shortest side length, x, we could say that our 9 centimeters has to be equal to my shortest side length times the square root of 3. I'm just setting up a little equation here by the facts that I know. Then I can solve for x. I'm going to not divide by 2, divide by square root of 3 on both sides. All right, and that gives me x over square root of 3, and then I just evaluated that, plugged it into my calculator, 9 divided by square root of 3, and I get a decimal of roughly 5.196. So that tells me that my shortest side length has to be I'll round it and say 2 centimeters, okay? And then to find the length of my hypotenuse, I'm just going to get rid of that up here because I think I wrote it wrong. To find the length of my hypotenuse, I just have to take the length of my shortest side and double it. So I took this number and I multiplied it by 2, and I got 10.39. So that means my hypotenuse has to be 10.39. Okay, not too bad, centimeters. Not too bad. All right, let's take a look at this with a cool little word problem. You know I got to end on a word problem here. So, the shadow cast from a building is 150 feet tall, and the angle that is formed between the building and the path of the shadow is 60 degrees. How tall is the building? All right, so what are we asking here? We're asking how tall this building is. I want to find this height. All right, so I'm going to say, this is my little question mark. How tall is that building? So what's the information we know? The shadow cast from the building is 150 feet. So this entire length, right, is 150 feet. And I'm going to probably assume that, the architecture structure is probably at a right angle. They built this thing perpendicular to the ground. So I'm seeing a right angle that's being formed. And also I know that the angle between the building and the path of the shadow, so I'm going to assume that it's this one since it didn't include information about the ground level, right? So I'm going to say that this angle is 60 degrees, and then here's kind of like my path of the shadow here. This last one has to be our 30-degree angle. So I know the side that is opposite of my 60 degree, and I know that the side that is opposite of my 30 degree has to be the smallest. So I'm just going to say that this is x, right? This length is a length of x, and I'm trying to solve for x. I know that if I take x and I multiply it by the square root of 3, I will get 150 feet, according to this special right triangle ratio. So now again, now that I've set up an equation, I can just solve for x. So divide by square root of 3 on both sides, and I'm going to get, again, those cancel out, I'm going to get x equals 150 divided by square root 3, but we don't like square roots in the or in the denominators. Just, evaluate this down to a decimal. What did I get? I got 86.6 feet. All right. So that means this height here, let me highlight it real quick. This height of my building, that missing side length, was just 86.6. Okay? 86.6 feet tall. And if we wanted to go even further, we could find this length of the hypotenuse just by multiplying that 86.6 times 2, right? Doubling my smallest side, and that would give me a length of 173 feet. Wonderful. So do not forget that ratio. I'm going to scroll it back up to the top so we review what we said, all right? So special right triangles are 30, 60, 90, all right? You can solve for any of those side lengths. You may have to set up an equation, kind of like what we did here, or maybe it's as easy as just doubling some side lengths here, or cutting some sides in half and then finding that. And smallest side always opposite the smallest angle, all right? So don't forget this ratio here. Please let me know if you have any questions. Otherwise, I'm going to attach a couple problems. And yeah, go team, you guys. Thank you so much for all of your hard work. I will see you later. Bye.